everybody. My name is Emre. I'm here to talk to you guys about our slogan, Less Trust, More Truth. I'm really excited to be here. I am welcoming you all to the New York Decoded stage. And yeah, let's dive right in. So, my name is Emre. That's another slide that says that. What I want to do now is I want to unpack this slogan. It can be a little controversial when you first hear it, right? It's a little bit of like, reducing trust sounds a little dangerous, right? It seems to be, there we go. Reducing trust sounds a little dangerous, right? Because trust is somewhat of a important thing in our social fabric. A lot of things are based on it and depend on it. So in the slogan, I'm going to break it down to its core components: truth, trust, and I'm also going to throw in there consensus, because I find that to be an important part of the equation. So what do we mean by truth? Truth is a finicky topic, right? Especially nowadays with fake news and a lot of people having their truth. You have your truth, I have my truth. Truth seems to be a relative thing. So there are many forms of truth, but let's contextualize this, let's not get lost. Truth in the world of blockchains is the verifiable state of the network, of the blockchain, right? So we want that to be the truth that we're talking about in this slogan. Next up, we have trust. Trust is also a really important part of the equation. However, it seems that right now, the current form of interactions we have in our society and civilization, there are a lot of dependencies on highly centralized forms of trust. We trust our banks, we trust our governments, we trust each other in society as well. And sometimes, trust taken too far can be blind faith. And that, in a way, could be dangerous, especially if some of these trusted entities fail, right? That can be potentially catastrophic. So it seems that we are working with technologies that will allow us to reduce some of the trust that we put into these centralized entities. That's what we mean by trustless. That's what we mean by less trust, more truth. We want more verifiable truth. Now, consensus happens on many scales in society, right? So one-to-one, we have agreements between each other. We have our laws that we, hopefully most of the time, agree to, right? So we have our things that governments are based off of, things that medicine is based off of. These are forms of consensus that we come to agreement together on. To a certain extent, they all happen. They all have a consensus happening at different layers. Truth ends up depending on some sort of a consensus. And in the blockchain realm, consensus is an important part of the design. The design of blockchain networks depend on a really important consensus mechanism. So that means truth can be relative, and if it doesn't depend, sometimes even if it doesn't depend on some objective truth that we might not even know what that is. So consensus is the glue that binds the truth and the trust and truth. Too much trust in centralized entities, centralized and closed entities, can be dangerous. So now that we've kind of dissected those terms, I'd like to talk about decentralization. Is decentralization a part of a natural phenomenon? Decentralization happening on many different scales, decentralization happening on societal scales, planetary scales, molecular scales. So what is decentralization, and can we kind of harness it? Decentralization seems to me to be a breakup of power, right? So Bitcoin was not didn't happen out of nowhere. It was a direct reaction to the 2008 financial crisis. It was a reaction to a piece of financial, the way that we organized financially, and that failing us, that we've put a lot of trust into. And so that decentralizing that made sense. we can extend this to a lot of different things now. We can decentralize governments. We can decentralize how we come to consensus. We can decentralize organizations, social networks. But we need to make sure we make the right decisions. I'd like to take a few interesting examples of decentralization happening on different scales. Planetary scales. We have a formation of a solar system. We have a cloud of, I'm no physicist, matter. And matter, as it bonds and densifies and starts having its own gravities, starts spinning around each other, starts to centralize into different objects, such as planets and suns and moons. But then what happens? A sun, as it ages, can decentralize. What about on societal scales? Having too much trust on a centralized form of government could be dangerous, especially if it's the person sitting on the seat doesn't have a logical perspective of governance. That could lead to some sort of a decentralization through revolutions, as we've seen. So then there's an opportunity to make better decisions about how we format our societies. This is an image, I hope, of what represents democracy, a representative democracy that we have now, is a decentralization of a certain piece of power of governance. What about on molecular scales? Well, first, I want to look at this interesting image. This is how Congress, the US Congress, has become more polarized over time since 1970s. But this is representing how they voted, whether it was within their party or with other parties. What does this look like to us? It almost looks like a cell splitting, right? So is decentralization kind of a process that happens on many levels all the time? And if we can harness that understanding, we can make better decisions about how to format our new ways of interacting with one another. What about entropy? Entropy is the second law of thermodynamics, where molecules are becoming more random over time, therefore decentralizing, right? So decentralization, in my view, is an opportunity to make better decisions and structure new ways of how we can structure society in new ways, in better ways, by making the correct decisions about how we base our consensus, trust, and therefore our truth. So, coming back to this less trust, more truth. Trust taken too far can be considered blind faith. That's dangerous. So, how does Polkadot provide a decentralized source of truth? I'm going to talk about 4 examples. Example number 1 is its design. Polkadot, by design, is a trustless system. And then I'm going to talk about light clients. Light clients are a really important part of decentralizing a network. I'm going to talk about governance. And I'm going to talk about Project Liberty. So, the trustless design of Polkadot. From the beginning, Polkadot's design has been quite trust-free. Decentralization and scalability has always been in the forefront. Through using open source technologies that are easily auditable and open, anybody can view what the source code of Polkadot and its modules are. Therefore, it's not a closed system. Open source technology is inherently a more truth-based form of developing products compared to a proprietary software that is behind closed doors. So anybody can open it up and look and see what's underneath the hood. This is really powerful, right? And it's also extendable. Polkadot's design, whether it's governance, cryptography, or game theory, economics, all of these can be extended to design better governments, better currencies, better organizations. Polkadot's design allows for experimentation. This is really exciting. Also, we have our light clients. Light clients allow a network to be further decentralized. Substrate Connect, for example, is an implementation of a light client. A light client implementation that allows functionality to be ran even in the browser, and without the need for RPCs, points of centralized points of data that we need to connect to get information about the chain. It allows for further scalability by allowing more nodes in the network, reducing the barrier to entry by further decentralizing. Governance. The governance on Polkadot is really an integral part of the design. It's also, interestingly, allowed Polkadot to be the largest DAO by treasury size that is also a sovereign blockchain in its own right. This is really interesting because the governance is baked into the design. What? I'm not sure what happened there. There we go. Sorry about that. The governance is baked into the design, and there's interesting updates coming to governance. Gavin is going to be having a talk about this later in the day, so tune into that for more in-depth detail. But Governance 1 has been on production for 2 years now, and it's allowed DOT token holders to decide on how the network gets updated and how the runtime changes, how the code changes. This is powerful because it's allowing the decisions to be made by the community. And Governance version 2 is going to enable that even further, making it more agile, more inclusive for the community, more decentralized, and by dissolving two important portions of Governance version 1, which is the council and the technical community, and replacing that with a community-based, the fellowship, which is a community-based form of governance that has, words are not coming to me, not responsibility, help me out here, it's coming. It's not coming, apologies. So then we have Project Liberty, an initiative by the Unfinished organization. A couple people from Unfinished are going to be giving a talk today, so tune into them to learn more about their organization as well. Project Liberty is a way to disrupt social networks, and they're going to be building it on Polkadot, which is really exciting. Through their technology, which is the Decentralized Social Networking Protocol, a new protocol to develop social media platforms on, where the truth will be more verifiable, easier by people that are a part of the network. Through a governance, rules designed and created by the community for the community, and it's, you've seen how difficult it can be to interact with closed-off social networks, and a movement. Project Liberty is a movement that allows for people to get behind and create new societal, design new ways to interact with each other in society in the ways in social networks. So yeah, these are the ways that Polkadot is working on providing a decentralized truth. So now I want to go back to the word that I forgot. So in the new form of governance, community members will have more power. By removing council and technical committee, there will be a sorry guys, COVID brain. And that'll be it from me, actually. So, but the takeaways will be that too much trust in centralized entities can be dangerous. So we have an opportunity here with decentralized systems to remove the amount of trust we have in these centralized entities and create more verifiable, decentralized forms of truth. Polkadot reduces the amount of trust needed to receive that truthful information. Centralization and decentralization can be harnessed. If we can know what part of the decentralization cycle we're in, we can make better decisions about how to build decentralized ways of interacting with one another. And decentralizing societal functions require meaningful technologies. Polkadot allows an ecosystem to be able to test these technologies and develop new exciting ideas about how we can structure society. Polkadot's design also allows for that experimentation, and you can just develop a parachain if you have an idea, and test it on the test networks, put it on Kusama, develop your community there, build your network, put it onto Polkadot. This is a really important design system because before that, you had to build your network from scratch. So Polkadot allows that layer 0 interoperable layer for you to be able to connect to and experiment. So I think ideas can be developed faster and quicker. Thank you for your attention, everyone.
Just a few housekeeping notes before we go to our next talk. Number one, there will be a QR code on the screen from time to time, including, hopefully, in a moment. If you scan that, it'll be a link to download the Hopin app, which you can use to view the presentations, which you don't necessarily need to do because you're here. But importantly, for the speakers that are going to be asking or having a Q&A session, you'll have to ask the questions through the Hopin app. So make sure when you have a chance to download the Hopin app, you can also find it through your usual internet searches, but that QR code will take you directly into the app download. You can register for the virtual version of the event, and when speakers have a Q&A session, you ask the questions through the app, and you can also upvote questions that you're particularly interested in. Another note, there is a second stage downstairs with some more technical talks, code demos. I invite you all to check that out. The agenda is also hosted on the Hopin app, so please take a moment to download that app. Next up, my good friend and colleague at Parity Technologies, Sean Tabrizi, will be discussing what XCM will mean for the multi-chain future. Thank you.
Hey everyone. Okay, good, it's working. Quick warning real quick. I've been known to speak a little bit fast. I'm sorry. If there's anyone on the stage who wants to slow me down, you can wave your hands, but otherwise there's a lot to cover, so maybe this is an advantage because you can get more information from me that way. Yeah, so I'll be talking to you about XCM, which is going to be the backbone of the multi-chain future. And some of the topics I'm going to be covering throughout my talk: what is interoperability? What is XCM? Obviously a very important topic. Why is XCM useful? And of course, the multi-chain future so far. But before we go into that, let's talk about Polkadot's mission, right? Let's just make sure we're all on the same playing field here. So Polkadot's mission is really about creating a scalable blockchain future. And we believe that the scalable blockchain future is a multi-chain future, where each individual blockchain can be optimized and specialized for a specific need. And through that optimization, you can achieve better scalability. Now, with a multi-chain future, lots of different blockchains, you may worry that one blockchain, if it's not secure, may be the entry point to attack the larger network. But with Polkadot, this isn't an issue because we provide shared security. Basically, every single parachain, these blockchains in this multi-chain future, they all get the security from the Polkadot network. And through that, basically, every single chain, no matter what product you build, no matter what kind of token you have or anything like that, is secured through Polkadot. And finally, the topic we'll be talking about most today is interoperability. Like, this multi-chain future really isn't that useful unless you can have these blockchains communicate. And so this is really what we're going to talk about today with XCM and XCMP, interoperability and communication between different parachains. So what is interoperability? Interoperability, going from the dictionary definition, is the ability for computer systems and softwares to exchange and make use of information. And note that there's two key verbs here: exchange and make use. This is going to tie to the two main things we're going to talk about today. Exchanging of information is through XCMP, and make use of information is through XCM itself. So let's go into these two topics. XCMP stands for cross-chain message passing. It is a networking protocol provided by Polkadot to pass messages between parachains. So as you can see, if you want to have two different parachains talk to each other in Polkadot, they use XCMP. Note that when you're communicating between different parachains, there's actually two kinds of channels you open. One is like an outgoing channel and an ingoing channel. So for every single two parachains there, there'll be two channels open to facilitate communication between the two of them. Now, every parachain has access to open these channels, but they're not open by default. So if you want to talk to a different parachain, you basically have to set up a handshake and say, hey, I'd like to talk to you. And the other one says, yep, I'd like to talk to you as well. This is to ensure that we keep these parachains safe from malicious parachains that might actually want to send or spam them messages. Another kind of message passing, which is not often talked about, but is kind of wrapped up into the same kind of world, is VMP, or vertical message passing. Vertical message passing is basically the same thing, where parachains they can talk to the relay chain instead of each other. And of course, there's a lot of different communication that parachains do, talking to things like Polkadot to coordinate upgrades, to coordinate all these other kinds of messages. So XCMP and VMP messages are opaque blobs. So at the protocol level, these message passing protocols don't assume anything about the message format. And this is really important. When you're creating a blockchain system, you want it to be relatively unopinionated. The more opinions you have, the more assumptions you're placing into the now, into what's good today. But really, with these kinds of generalized message passing protocols, you basically want to assume that all the messages are these opaque blobs, basically just bytes. And so we don't assume any specific message format. But, of course, having a standard message format is useful, because if you don't have a standard, then you're basically leaving it to everyone to kind of figure out their own standard and make their own thing. So having standards is nice. And that is, of course, where XCM comes in. So what is XCM? XCM stands for cross-consensus messaging. And actually, if you note here, XCMP stands for cross-chain message passing. The C is chain in XCMP, but in here it's consensus in XCM. And I'll talk a little bit why that is the case. The XCM format is a basic format for communication between consensus systems. And consensus systems is kind of, I think, maybe a unique word. Maybe some of you are just hearing for the first time. But what it really means is basically it's designed for any type of system which derives consensus. So that is parachains, but that is also bridge chains, smart contracts, and much more. I wanted to clarify that XCM is not a Polkadot or parachain-specific format. It works and is designed to work across any consensus system. So here's an example of what that might look like across many different consensus systems. So in this picture, you have basically an Ethereum smart contract initiating an XCM message, sending it over an Ethereum bridge to like a bridge parachain, then that passing from a bridge parachain over XCMP to another parachain, where on that parachain there is a contracts palette that uses ink, and actually that message is getting processed by an ink smart contract. So you can see in this diagram, you basically are taking the same XCM message, this kind of agnostic message format, across many different consensus systems, across many different messaging protocols. But it works because it's designed to work across any consensus system. And that's really exciting. And these kinds of scenarios, while they don't quite exist today in Polkadot, are exactly the things we're trying to build towards, where we can really connect entirely different systems and parts of this Web3 world together. So XCM is designed around 4 A's. And all the design decisions around XCM is about these different points. The first is agnostic. And I've already been talking about that for a while now. This format is meant to be agnostic to whatever consensus system you want to use. So we don't make assumptions about it. We just want to make sure that it's usable across different kinds of smart contracts, bridge platforms, parachains, anything of the like. We also assume it's absolute. So it's important that XCM messages are used within systems where things are guaranteed to be executed and delivered and interpreted correctly. So we can't do this in non-deterministic settings. We can't use this in a place where you're not sure if the message will get there or if it'll be dropped. We want to make sure that these messages, when they're sent, they're being processed correctly. It's asymmetric. This means that messages do not have a result. And if you want to get a result of a message, you have to basically have someone send a message back to you. Now, this is basically a realization that sending messages, especially over systems like Polkadot, is quite expensive. You're basically sending a message over 2 different blockchains and having them interpret each other. You can imagine if I say hi and you're waiting for someone to say, yep, I got your hi message. This is a lot of wasted resources. So basically, we want you, when you design XCM, assume most of these messages are fire and forget. That whatever you've designed can be sent, It can be processed, and it can even handle its own errors if needed. And finally, Xcm is asynchronous. So we don't assume that anyone's blocked on any message, that messages can go in, and again, much more of the fire and forget type methodology. So if we want to go deeper into Xcm, we can basically simplify it into 3 main parts: multi-locations, multi-assets, and instructions. And so I'll go over each of these ones one by one. Multi-location is an abstract and general way to reference objects inside the topology of a consensus system. So basically, if you want to identify any of the different things that you see in this picture, you can use a multi-location to do that. Now, multi-location is a relative identifier. In the Web3 ecosystem, there is no start or end. It's just a giant mesh of different consensus systems. So we can't say starting here or starting there. We have to do relative paths. So in comparison to where I'm at, this is what I want to reference. So a basic example is if I'm on a parachain, any of these parachains above, and I want to reference Polkadot, the relay chain, I would just use this, .. which means parent. If you're familiar with file systems on your computer, if you ever go up a file system, you use just the parent notation. If you want to reference between 2 parachains, you basically say, OK, I want to start with the parent, so go up to the relay chain, and then go to the parachain I want to communicate. So parachain 3000, for example, would say .. and then parachain 1000. That's how you can access parachain 1000 from the reference point of parachain 3000. And similarly, you can go even further. If you want to go one step further than that, actually not just target a parachain, but resources on the parachain. That would be like users or assets. You just continue to add that to the file system. So you can see basically we're creating a relative path to access the resource you want to target. And so multi-location is very abstract, very general, and really easy to use. Next, we'll talk about multi-assets. So obviously, we're looking to build a multi-chain future. There's going to be lots of tokens, lots of NFTs, lots of fun stuff. And so being able to access and reference them within Xcm is very important. In Xcm, we support both fungible and non-fungible tokens. And basically, we can reference them quite easily using things like multi-location. So I'll give you an example. If we want to reference the dot token from a parachain, you can see here there's kind of a little bit of a structure here. But the main piece here is that the ID of the asset is the concrete asset at multi-location parent. So again, I'm a parachain. I want to know the dot token. I say it is the concrete asset of my parent. And that's how you access dot. Similar to the other things, if you want to access the token of another parachain, you basically update the multi-location to the correct parachain multi-location place. And of course, you can reference how much tokens you actually want. So that's pretty easy, I think. And finally, we have instructions. So instructions is basically a way to convey what actions should I take in a consensus system. So I have a message. What does the message actually tell me to do? Well, basically, I have some references to multi-locations. I have references to assets. Here are the instructions, the step-by-step things you should be doing with these assets and locations to actually process a message. Now, there's a lot of different messages. I'm not going to cover them all. This is just a few of them. But you can think of them as building blocks. We can increase the number of messages. We can add more. And this increases the flexibility of what you can do and what you can achieve with Xcm. So why is Xcm useful? So I mean, this is kind of interesting. I showed you the building blocks. But where does it actually get used? Well, Polkadot is designed for modular, upgradable parachains. And this is normally the part where I would talk about Substrate, and Substrate being this amazing blockchain framework which allows you to design and sculpt exactly the kind of blockchain you want. And not only that, but upgrade it all the time. Now, Substrate would be its own entire talk. I encourage you to find it online if you're not familiar with Substrate. But the idea is Polkadot is designed for these parachains where they can constantly change, constantly be upgraded. So let's take an example. Let's say that we have set up 2 parachains to talk to each other, right? And we use just XCMP, not Xcm. So we have this opaque message blob from one parachain to another one trying to communicate some instructions. Now, this can work. You can set it up ahead of time and say, hey, these 2 parachains are working together well. But the problem happens that when you upgrade one of the parachains, the other parachain needs to know about the upgrade, right? This coordination of upgrading is very difficult. So you could have it where one chain upgrades, the other one hasn't upgraded, and these messages are then getting sent to the wrong place, the wrong actions are happening. This could be really bad, especially when you're managing multi-billion-dollar systems. These messages can be very complex and very valuable. It's important that these kinds of systems don't exist, where basically messages are getting lost. So instead, Xcm defines a standard language for how common actions should happen between consensus systems. So if we look at the new scenario using Xcm and the Xcm executor, you can see that when I'm setting up to send a message, I actually construct that message as a set of Xcm instructions, like things you should do. This can then be converted to bytes, gets passed over to the parachain, the second parachain, where they have an Xcm executor. This Xcm executor you can think about as a processor. It processes the instructions, understands the intention of the message, and then routes that to the appropriate place inside of the actual parachain. So again, independent of this parachain B changing or manipulating, the Xcm executor, which is also controlled by parachain B, can be upgraded to then always route the messages and instructions to the right place. And so this is the way that we can make sure that messages always get processed correctly and into the right thing, no matter how different parachains upgrade. And this is really why Xcm is so important. If we want to build this multi-chain future where everyone can upgrade and be the best specialized blockchain they can be, it's really important that we have a meta protocol on how we can make sure messages are always being interpreted and passed correctly. Right? Does it make sense? Some nods in the okay, good. So let's talk about the multi-chain future so far, and how people have been using Xcm and XCMP. So today, there are over 70 channels open on Kusama, which connects all the different parachains to one another. This doesn't even include the connections from each of these parachains to the relay chain, which everyone has by default. But basically, every single one of these open channels means that there is a message, or there is a agreement between these two parachains that's saying, hey, I want to share messages with you. And as we increase the number of parachains, the number of channels that will open will grow exponentially. So that's really exciting. There have been over 150,000 total Xcm messages sent. And let me clarify, this is, we're still very, very early into the Xcm world, but it's very exciting to see there's so many different messages being sent and being used already on the network. I want to go over a few of the different scenarios that the parachain teams have been using to let you know kind of what's going on. So I'll give you an example. Moonbeam, the great host of this event, they're using Xcm to send messages to EVM contracts. So as you might know, Moonbeam supports an EVM system where you can design EVM contracts and basically take your Ethereum smart contract and bring it to the Polkadot ecosystem. But again, that bringing it to the Polkadot ecosystem wouldn't be very useful unless you can actually bridge it and connect it to the other parts of the Polkadot world. So they're using Xcm to basically allow users, parachains, or other contracts to talk to the legacy EVM contract world. And this really gives value to the ecosystem that they're trying to build. You have Akala. Akala is using Xcm to create this liquid staked dot. Basically, if you know in Polkadot you can stake your tokens, you can help secure the network. But with Akala's protocol, you can actually use Xcm to transfer these tokens to Akala and create this liquid token, which can still be traded while it's staked. Then on the Akala side, they use Xcm, they take in your token and basically create a bunch of accounts and use that to create nominators, which stake against other validators in the network. And basically make sure that your token can be traded while also being used to secure the network. And all of this happening with Xcm, XCMP. A-Star is another team that's using Xcm, and they've used it just recently to extend their parachain slot. So as you might know, the first year of parachain slot on Kusama recently ended, and in order to ensure that their blockchain continues without downtime, they use Xcm to basically extend and add more lease periods to their blockchain, ensuring that it stays up, it continues to work, and that everyone can continue to use A-Star without any downtime. And finally, Polkadot uses Xcm itself. I mentioned these the VMP messages. Polkadot has been using Xcm to govern common good chains. So there are these chains, for example, like statements, which are common good chains. And these chains don't have any native token, they don't have any native governance, but they're completely controlled and managed by Polkadot itself. So Polkadot governance can go ahead and send a message to control the statement parachain and coordinate runtime upgrades. And this has been a really powerful way that Polkadot has been able to basically extend its reach and allow it to grow in ways beyond just a single chain itself. I guess the real takeaway here is that Polkadot is itself a part of the multi-chain network. Polkadot will not be just one chain in the future. It'll be many chains connected to a relay chain. And so what you know as Polkadot today will actually be many common good chains. Yeah, so I guess, the summary of all this is that, Xcm is just really one of the many building blocks towards a multi-chain future. If you look at Substrate, it's this really extensible blockchain framework. If you look at Polkadot, it's really just a sharding solution. XCMP is a protocol for passing messages. Xcm is a message format. All of these different tools are interesting, but they don't really move us forward in the future. But when you bring them together and you actually put them all together and you get those amazing scenarios that I've described, and even the ones that I don't even know are going to happen yet, this is really how we get towards the multi-chain future that we all need and we really expect. And so I guess my question to all of you after this is, I want you to tell me about your vision of a multi-chain future. I want to know what you guys think is interesting, how you're going to use tools like Xcm to achieve that, and really help shape us in the direction of how we want to take this and how we want to build these technologies to satisfy your needs. And yeah, this is my name, my information. Contact me, find me around here, and thank you so much for listening.